Agriculture is one from the human activities which is for which are now very important information. Agriculture is under big press of surrounding environment, and there is a lot of challenges or external factors which are influencing agriculture production. And it is important for farmers to have this information and to be able to work with this information. As example could be information about environment, price, energy cost, but also about demographic growth, etc. Farmers need also collect information on the level of the farm and exchange information with many external bodies like revenue offices, like subsidies organization, etc. So there is very important interoperability of data. It is necessary to consider that every system, every supplier, every customer of farmers use different systems, and it is very difficult to manage data together. So this was the reason why we inside of Common IP project start to build open agriculture services. The first priority of open agriculture services is to guarantee interoperability of agriculture data, usage of this data in interoperable form, and using this information for management of production on the level of the farm. We implemented two cases. First case is tactical production planning.
Well, about the tactical production planning, there is a situation that a farmer has several lands, and for growing on these lands there are available several kinds of products. And the goal of the tactical planning is to recommend to farmer which products choose to each of the lands to maximize his expected profit. Well, several constraints has to be satisfied, that not each of the product is available for growing on each of these lands because of some crop rotation history and things like that. And there are also factors affecting profit, like each product is more suitable. Some products are more suitable for some lands more than other products, etc.
To build the system for tactical production planning, we need to establish relatively complex systems, guarantee to access to the data, transformation of the data, but also to preparing the plan and also visualization data. For the purposes of the tactical planning, we need on one side internal information on the farm level, which are usually collected in the form of digital maps. To be possible take information from digital maps, there is implemented there is used existing legacy platform Pre-Farm, which is managing information on the level of the farm, but there are used tools which allow us to derive information from the maps. The goal is to transform the information from the maps into table form. Other resources of information could be sensors measurement, and for sensors measurement they are implementing interoperable tools collecting and publishing data from sensors. Last type of information are external information coming from outside. We need to know the cost of energy, the cost of materials during this season. We need to know, for example, the prices which was used on the market for agricultural production, but also, for example, there could be information about the prices from this year from South Hemisphere, which could influence the future prices on the level of the farm. This information are coming in different forms. As I mentioned already, the incoming data from prefarm are map data, which has to be transformed into a table form, which is used there by optimization method. Some external data, some statistic, for example, could be Excel file. Some data are stored in databases. To be able to transform all this data, which are in different models and which could have every year different model, we are using the coin MDIS component, which allowed us to transforming data model into internal model of optimization system. Now I would like to ask Karel to tell something about optimization system.
Well, the optimization module is using mixed integer linear programming approach to solve the problem I described before. Well, now we have all necessary data and we can formulate the problem. So the expected profit is objective function which we are trying to maximize, and the other components of the model are constraints, which are given by crop rotation and some personal farmer preferences. As the part of optimization module, we are using tool which is open source, and it is called PULP, and it is a Python modeling library. The Python modeling library is used to create the model of the problem we described, and then the PULP is calling CBC module, which is also open source, and it is optimization solver. The optimization solver is used to solve the model and to provide the optimal solution of the optimization problem.
The outputs from the module for optimization could be all used in the tabular form, where it could be, for example, presented as Excel file, but what is more suitable for farmers, it's the possibility again to display the result of the optimization in the maps, and farmers can check in the maps the recommendation from optimization module. We are able to prepare more the maps with different variants, and final decision about production depend on the farmer. In our testing, we use advantage of existence of prefarm system. Prefarm system is a system for recommendation for precision farming, which is running now in Czech Republic on the area of almost 7% of arable land in Czech Republic, and we provided the test with 3 big farm using prefarm model with average area of 5,000 hectares for every farm. So they are really big farm, and this farm are main drivers for agricultural production. We recognize that on such type of the farm, really the planning is difficult, and this module was very well accepted by farmers, and we expect to start to use this on the first farm operationally from next season. The model, what we expect to use for this tactical planning is model software as a services, and in principle farmers will pay the cost related to area of hectare on which they are produce their agricultural production. The second use case which we implement is search for machinery providers. It is also very important for farmer. There are machinery like tractors which are used almost every day in the production, but other machinery like harvesters are used only for a few days for the season, and if we consider that the cost of such machinery is some 100,000 euro, it is very expensive for farmer to buy such type of machinery only for a few days of production. So there exists in principle 2 possibilities, and both these possibilities are covered by the second module, search for machinery providers. One is that there are service organizations, like in the case of the Czech Living Club MGM organization, who is able to offer to the farmers their services, and farmers are not necessary to pay directly for machinery, but they are only paying for the services provided with the machinery. In other case, when farmers are owners of machinery, it could be advantage for farmers to share the part of capacity of this machinery with other farmers. So the system, which is based on semantic search and which is based on the tools developed by Coin, allowed us describe the machinery and the task provided with this machinery with the ontology, and farmers can look and search for necessary services, service provider and machinery which could be available in his region and in a concrete time. For this second type of services, there will be necessary some longer time to start run with the services operation. Why? The advantage of such system will grow when more farmers will be registered in the system, and when more farmers will start to offer their services using this search for machinery providers. And there is something like effect of social network, with growing number of machinery, with growing number of farmers registered in the system. There is growing the quality of services, and people are more willing to use the services. So our decision for this second type of services is start with offering the services first year free of charge to attract some bigger number of farmers to start use our tools. Generally, I would like to say that the Coin project helped us to understand new possibilities about the cooperation, and also the importance of interoperability for cooperation. We are sure that we will be able to continue in the future in the close cooperation with other partners to extend the services, because we see the large possibility in agriculture sector for building of new interoperable collaborative services.